product of algebraic expression. How you can multiple the algebraic expression. So I just show this pattern. Okay, by using this pattern, first I will just give an intro how to make a product. Okay, so first you can see it mentioned brown and pink color. For example, it is the monomial term, multiple of monomial term. Multiple of monomial term with the same variable or different variable. Okay, only addition and subtraction you may consider about the like terms. Like terms only you must add and subtract, but in multiplication there is no problem for like terms and unlike terms, whether the variables are equal or not equal, or not equal with the same exponents, no problem at all. Okay, for example, you can see it's brown and pink. If you multiple, you get an value like this by the product brown and pink. For example, if I take this is x and this one is y, so now you can take x into y, it become a xy. So x is a different variable, y is another different variable. In multiplication, just you multiple. So what is the coefficient of x is 1, and here also 1. So first you need to concentrate the number. 1 into 1, 1. X into y, xy. Likewise. Okay, so if I just denote here binomial with monomial, the product of binomial, because I take this is two terms. Okay, so I just take it as a 2-digit number. I just mention with all plus. Okay, all plus. All plus. So now you can take over. Pink can be multiple with the black. Okay, you get this product. So first you go with this term to this one. Okay, and next you need to go with the brown, that is other term. And before that, what is the symbol? You have a plus, you put plus, and here you can take this is also plus, so plus into plus you put plus. So pink with the brown. Okay, so likewise binomial is multiple with the binomial, all are plus only. I won't go with any different symbol, it shows only positive. I have to take all the values in positive. Okay, so you can see first I just go with this blue to black, and then next I go with the blue to brown, blue to black and blue to brown, and next I go with this pink and pink to black, pink to brown, pink to black, pink to brown. Okay, you know the identities by the product, whether you get plus into plus, you get plus, minus into minus, you get plus, plus into minus, you get minus, minus into plus, you get minus. For an example, you can take commonly same symbol, by the product you get plus is the answer, and different symbol in a product you get minus in the answer. Whether it is greater, smaller, no need to consider about the greater, smaller. By the product you just concentrate whether same symbol plus, different symbol minus. This is the main concept to multiple through over the integers, and also in a algebraic expression to multiple different terms. Okay, so next we move on to trinomial with the binomial. So first I take over this black term and multiple with the first orange, brown, blue. It may take any variable, it may take any numbers, whatever it is, you just concentrate first term with this 3 term. You multiple, normal multiplication dear. For example, 325 into 17. First what you need to do, you must multiple all this 325 with 7. Instead of 7, you take the first term, multiple with this 3 term, And next you go to the tens places, same way you go to the second term and multiple with all the term. You can see black orange, black brown, black blue. Next I go with the pink orange, pink brown, pink blue. So this is the set. It denotes multiplication of binomial with the trinomial. So here binomial I mentioned in the color black and pink. Okay, with all the other three terms. So black it present in a three terms and pink it present in a three terms. Now you got an idea.
Question 1, we have to find the product in each part of the given pair of monomials. So let's start with the first part. In the first part we have the monomials 4 and 7p, which we have to multiply. So we have to calculate 4 into 7p. So we can multiply the coefficients separately. So 4 is the coefficient of the first term and 7 is the coefficient of the second term. So 4 into 7, and then we multiply the variable parts separately. So there is no variable part in the first term 4, but in the second term we have p. So we have this term p in the product. So 4 into 7 is 28 and 28 into p is 28p. So this is the answer for the first part. In the second part we have minus 4p into 7p. So we have to calculate minus 4p into 7p. So once again we multiply the coefficients separately. So minus 4 into 7, and then we multiply the variable parts p and p. So we have into p and p. So minus 4 into 7 is minus 28 and p into p is p square. So we will get minus 28 as the coefficient and p square as the variable part, as the algebraic part. So minus 28p square is the answer, is the product in part 2. In part 3 we have minus 4p and 7pq. These are the two terms we have to multiply. So minus 4p into 7pq. This is what we have to calculate. So once again we multiply the coefficients separately. So minus 4 into 7, and then the variable parts will be p from the first monomial and pq from the second monomial. Now minus 4 into 7 is minus 28, and what about p into pq? So we have two repetitions of p, so that will become p square, and then we have a q, so p square q. So we will get minus 28 p square q. This will be the product in the third part. In the fourth part we have 4p cube minus 3p. So 4p cube into minus 3p. So we multiply the coefficients separately. So 4 into minus 3, these are the coefficients, and then the variable parts are p cube and p. So we have p cube into p. So 4 into minus 3 is minus 12. So we get minus 12 as the coefficient, and p cube into p is p to the power 4. So we get minus 12 into p to the power 4. This is the product in part 4. And finally coming to part 5, we have the terms 4p and 0. So 4p into 0. So we can multiply the coefficients. 4 into 0 into the variable part is p, but 4 into 0 is 0, and 0 into p will also be 0. So we will get the product as 0. This is the answer for part 5. And with this we have completed question number. The problem statement in question 2 says, find the areas of rectangles with the following pairs of monomials as their lengths and breadths respectively. So we are given these 5 pairs of monomials, and in each pair one monomial represents the length and the other monomial represents the breadth of a rectangle, and we have to find the area of the rectangle. And the area is, we know that the area of a rectangle is simply length into breadth. So all we have to do is multiply the two monomials in each case to find the area. So in the first part, the two monomials are p and q. So the area will be simply the product of these two monomials, p into q, which we can write in shorter form as pq. So this is the area in the first part. In the second part, we have the two monomials as 10m into 5n. So the area can be written as 10m into 5n. Now let's multiply the coefficients separately. So 10 into 5 is the product of the coefficients, and then the variable parts, the algebraic factors, are m and n, so we multiply those. So 10 into 5 is 50, and m into n can be written as mn, so we can write the product as 50mn. This is the area expression for the area in the second part. In the third part, we have 20x square and 5y square as the two monomials. So the area will be 20x square into 5y square. The coefficients are 20 and 5, so let's multiply them separately. 20 into 5, and the algebraic factors, the variable parts, are x square and y square, so let's multiply those separately. So 20 into 5 is 100, and x square into y square can be written as x square y square, so we can write the product as 100 times x square y square. This is the expression for the area in the third part. In the fourth part, we have the two monomials as 4x and 3x square, so the area will be 4x into 3x square. The coefficients are 4 and 3, so we multiply them separately, 4 into 3, and the variable factors, the algebraic factors, are x into x square. So x and x square are the two variable factors. Now 4 into 3 is 12, and x into x square can be written as x cube. So the product can be written as 12x cube. So this is the area expression for the fourth part. And finally, in the fifth part, we have the two monomials as 3mn and 4np. So the area will be 3mn into 4np. Now the coefficients are 3 and 4, so let's multiply them separately, 3 into 4, and the variable parts, the algebraic factors, are mn and np, so we multiply them separately, so mn into np. Now 3 into 4 is 12, so this is the coefficient in the product, and mn into np, so there are two repetitions of n, so this will become n square, so we will get mn square p as the variable part or the algebraic factor in the product. So the five parts of the answer are pq for the first pair, 50mn for the second pair, 100x square y square for the third pair, 12x cube for the fourth pair, and 12mn square p for the fifth pair. And this completes question number 2. In question 3, we have to complete this table of products that you see here. Each product in the table is calculated by taking the first monomial from the topmost row and the second monomial from the leftmost column. For example, if you take 2x as your first monomial from the topmost row and 2x as your second monomial from the leftmost column, the product you get is 4x square, which is already mentioned in this cell, because 2 into 2 is 4 and x into x is x square. Similarly, if you take 3x square as your first monomial from the topmost row and minus 5y as your second monomial from the leftmost column, the product that you get is minus 15x square y, because 3 into minus 5 is minus 15 and x square into y is x square y. Now we have to fill up all the other cells of this table in a similar manner. And because there are many cells to be filled, I won't write out the detailed calculation for each case. Instead, for each combination of monomials, I will simply observe the product of the coefficients and the product of the algebraic factors and write the overall product accordingly. The other thing we note is that the sequence of monomials in the topmost row, 2x minus 5y, 3x square, and so on, is the same as the sequence of monomials in the leftmost column, which is also 2x minus 5y, 3x square, and so on. This means that many products occur twice in the table. For example, if you take minus 5y as your first monomial and 3x square as your second monomial, then the product you will get will be the same as if you take 3x square as your first monomial and minus 5y as your second monomial. And that product we have already calculated as minus 15x square y. So the product of minus 5y into 3x square, this we can write directly just by observing this product. We can fill this cell here also as minus 15 x square y. Okay, so we can just observe that these two products will be the same and fill this cell directly. So in a similar manner, we can fill a lot of the other cells in the table directly. Okay, now let's start off by filling the cells, and as I fill each cell, make sure you're observing the multipliers coming from the topmost row and the leftmost column. Okay, so let's come to this cell here. I'm just highlighting this cell here, which is 2x into minus 5y. So this will be 2x into minus 5y will be minus 10xy, and the same product will go here also in this cell, minus 10xy, because this is minus 5y into 2x. Now let's come to this cell here, which is 2x into 3x square. This product will be 6x cube, because 2 into 3 is 6 and x into x square is x cube, and the same product will go here also, 3x square into 2x. So this will also be 6x cube. Okay, now let's come to this cell here, which is 2x into minus 4xy. So this will be minus 8x square y, because 2 into minus 4 is minus 8 and x into xy is x square y. And the same product will go here also, minus 4xy into 2x. So this will be minus 8x square y. Okay, then we come here to this cell. This cell will be 2x into 7x square y. So 2 into 7 is 14. So we get 14 into x square y will become x cube y, because x is being repeated thrice. And the same product will come here also, 7x square y into 2x. So this will be 14x cube y. And then finally we come to this last cell of the first column, which is 2x into minus 9x square y square. So this will be 2 into minus 9 will be minus 18, and we have x into x square y square. So that's x cube y square, and the same product will go in this cell. Okay, and this cell also we can fill with minus 18 x cube y square. Okay, now we come to the column of minus 5y. So the first cell we've already filled. The second cell, which is this cell here, is minus 5y into minus 5y. So this will be minus 5 into minus 5 is 25, and y into y is y square. So we will get 25y square. Then we come to this cell here, which is minus 5y into minus 4xy. So minus 5 into minus 4 is 20. So we get 20 as the coefficient, and y into xy will be xy square. Okay, so we get 20xy square, and the same value will go in this cell also, which is again minus 4xy into minus 5y. So here also we can put 20xy. In question 4, the problem statement says obtain the volume of rectangular boxes with the following length, breadth and height respectively. So we are given these 4 parts. In each part we are given 3 monomials which represent the length, breadth and height of a rectangular box or a cuboidal box, and we have to find the expression for the volume of that box. So we know that the volume of a cuboid is simply the length times the breadth times the height. So we have to multiply length, breadth and height, which means that in each of these parts we have to multiply the 3 expressions, the 3 monomials, to get the expression for the volume. So let's do this. Let's start with part 1. In part 1 we have the length, breadth and height as 5a, 3a square and 7a to the power 4. So we have to multiply these 3 monomials. Okay, so we can multiply the coefficients separately. So the coefficients are 5, 3 and 7, and we can multiply the algebraic factors separately. So the algebraic factors are a square and a to the power 4. So 5 into 3 into 7, what is this product? So this is 15 into 7 or 105, and then we have a into a square into a to the power 4. So in total this is 7 repetitions of a. So we get 105 into a to the power 7 or 105 a to the power 7. So this is the volume, the expression for the volume for the first part. Now let's go to part 2. In part 2, the length is 2p, the breadth is 4q, and the height is 8r. So we have to multiply these three monomials. So we multiply the coefficients separately. So we get 2 into 4 into 8, and then we multiply the algebraic factors separately. So we get p into q into r. So 2 into 4 into 8 is 64, and p into q into r can be written as pqr. So we can write the expression for the volume as 64 pqr. So this is the volume for part 2. Okay, now let's go to part 3. In part 3, the length is xy, the breadth is 2x square y, and the height is 2xy square, and we have to multiply these three monomials. Now we can multiply the coefficients separately. So from the first term we have 1 as the coefficient, then we have 2 and 2 from the second and third terms, and the algebraic factors are xy, and then x square y, and then xy square. So these are the algebraic factors. Okay, now let's multiply. 1 into 2 into 2 is 4, and in the variable parts we have x, x square, and x. So that's a total of 4 repetitions of x. So we get x to the power 4, and then we have y, y, and y square. So again 4 repetitions of y. So we get y to the power 4. So the product we get is 4 x to the power 4 y to the power 4. So this is the expression for the volume in part 3. And finally, coming to part 4, the length in part 4 is a, the breadth is 2b, and the height is 3c, and we have to multiply these three monomials. So we multiply the coefficients separately. The coefficient in a is 1, the coefficient of 2b is 2, and of 3c is 3, and the variable or the algebraic factors are a, b, and c. So 1 into 2 into 3 is 6, and a into b into c is abc. So 6 into abc can be written as 6abc. So this is the expression for the volume in part 4. And with this we have completed question number 4. In question 5, we have to obtain the product in each part of the given monomials. So in each part we are given some monomials and we have to multiply them and find the product. So let's start with the first part. In the first part, the monomials are xy, yz, and zx, and we have to multiply these three monomials. So the coefficient of each monomial is 1. So in the product also the coefficient will be 1. And what about the variable part? So we have x into x, so that's x square. We have y into y, so that's y square. And we have z into z, so that's z square. So we get x square into y square into z square, which we can write as x square, y square, z square. This is the product for the first part. Now we come to part 2. In part 2, the three terms, the three monomials we have to multiply are a, minus a square, and a cube. So these are the three monomials that we have to multiply. So the coefficients of these three are 1, minus 1, and 1 respectively. So we can multiply the coefficients separately, and the variable parts are a square into a cube, and these we can multiply separately. So 1 into minus 1 into 1 is minus 1. So we have minus 1 into a square into a cube. So in all this is 6 repetitions of a. So we can write a to the power 6. So minus 1 into a to the power 6, which we can write as minus a to the power 6. So this is the product for the second part. Now in part 3, the terms we have to multiply are 2, 4y, 8y square, and 16y cube. So these are the terms that we have to multiply. So let's multiply the coefficients separately and the variable parts separately. So the coefficients are 2, 4, 8, 16, and these we will multiply separately. And the variable parts are, in the first term there is no variable part. In the second term we have y, and then we have y square from 8y square, and then we have y cube from 16y cube. Now 2 into 4 into 8 into 16, you can calculate this product. This will be 1024, and then we have y into y square into y cube. So that's 6 repetitions of y. So 1024 into 6 y to the power 6 repetitions of y. So this we can write as 1024 y to the power 6. This is the product in part 3. In part 4, we have to multiply a, 2b, 3c and 6abc. So these are the 4 terms that we have to multiply. So once again, we will multiply the coefficients separately and the variable parts, the algebraic factors, separately. So the coefficients are a has a coefficient of 1, 2b has a coefficient of 2, 3c has a coefficient of 3 and 6abc has a coefficient of 6. And the variable factors, the algebraic factors, are a, b, c and abc. Okay, so 1 into 2 into 3 into 6 is 36. And then let's calculate the variable part. So we have 2 repetitions of a, so we get a square, 2 repetitions of b, so we have b square, and we also have 2 repetitions of c, so we have c square. So the variable part is a square, b square, c square, and hence the final product is 36 a square, b square, c square. This is the product for part 4. Finally, we come to part 5, in which we have to multiply m minus mn and mnp. So these are the 3 terms that we have to multiply. Now the coefficients are 1, minus 1 and 1. So let's calculate their product separately. 1 into minus 1 into 1. And the variable parts are m, mn and mnp. So these 3 are the variable parts which we will multiply separately. So 1 into minus 1 into 1 is minus 1, and then we have 3 repetitions of m, so that's m cube, and we have 2 repetitions of n, so that's n square, and then we have just 1 repetition of p, so we have p. So this is the variable part, and hence the final product is minus m cube n square p. This is the product for part 5, and with this we have completed question number 5.
Thank you for watching our channel. This video உங்களுக்கு பிடிச்சிருந்ததுனா கமெண்ட் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க. மறக்காம இந்த சேனலை சப்ஸ்கிரைப் பண்ணிட்டு பக்கத்துல இருக்கக்கூடிய பெல்